Hello. Our project is to create a diamond mine tailing facility closure protocol. Our sponsor is Dr. Gail Heath, mentored by Dr. Brad Ross. Our team members are Carl Holliday, myself, Elizabeth Jones, Brandon Sims, Ryan Stewart. For our presentation today, we'll be going over our project description, the location and background for our project, our closure methods, our steps for closure, the closure budget, the risks to closure, and our monitoring system design. Now my colleague will get our presentation started.
Hi, I'm Carl Holliday. Our project description. The project required the team to do several things. The first one was determine the feasibility of several different closure methods. We selected a closure method. Then we created a closure protocol based off the selected method. And lastly, designed a monitoring system. Our location is in northern Canada. It's approximately 200 kilometers northeast of Yellowknife. Our background, the mine is owned by De Beers Group. The tailings is processed timberlake. It's stored on the northern pile. The mine closed due to several issues such as watering and flooding. The negative market conditions and diamond price also was a reason for closure. The mine is only accessible by airplane and ice roads.
For this project, we considered 4 different possible closure method options, one of which was to cover and cap the existing tailings pile. The second was to sell the tailings as a filler ingredient in paint, rubber, or toothpaste. The third was to sell the tailings to gold mines to neutralize their arsenic. And the fourth was to backfill the mine, the existing underground mine, with the tailings. We judged each of these 4 methods on 3 criteria. The first of which being the environmental impact that the method would have, the impact to the company's social license as a result of the closure method, and we attempted to gauge the regulator interest for each closure method. The higher the score that a method received, the less desirable the closure method would be. The lower the score, the more desirable. This led us to choose the backfill as our option for closing this tailings facility. This is because this method is environmentally friendly. It's already a method that's used widely throughout Canada and their mines, and it would remove most, if not all, of the tailings from the surface of the mine. In order to successfully close the tailings facility using backfill, we would first need to explore and analyze the underground workings to determine the amount of volume that we have to fill up. The second would be to construct our infrastructure, such as a mixing plant, a crusher, getting the equipment to the site, and setting up the pipe network. Our third step would be to begin backfilling the mine with the tailings. Then we would have to process the remaining tailings, which we estimate to be between 0 and 10% of the starting volume. This remaining tailings would be covered and capped and revegetated, and we would then monitor our closed facility.
Hi, my name is Brandon Sims. So for the closure budget, based on the survey data, we were able to approximate the total tails material to about 35 million metric tons. Our capital costs include the mixing plant, pumping station, equipment, and even a small crusher for permafrost. Next, we calculated our total cost per ton to move the tails, and we came up with $2.53 per ton, and multiplied that with our total tons. This brings our total overall cost to about $91.5 million. Next is our risk to closure. Inability to locate extent of workings. If the extent of the underground workings is miscalculated, then the amount of tails left could be larger than anticipated. This could result in an increased cost. Second is delays in establishing necessary infrastructure. This comes down to accessibility and weather conditions, possibly resulting in a delay. Thirdly, frozen sections of tailings delay excavation. So as mentioned previously, permafrost is a big issue we might face. We plan on combating this with dozers, ripping before excavation, and a small crusher. However, we are still expecting this to be a risk to operations. Fourth is a slurry settling in pipes. A pumping rate that is too slow could result in material settling in the pipe, thus creating a blockage and causing the need for the pipe to be replaced. Inadequate flushing of the pipe prior to pausing pumping could result in material settling in the pipe and creating a blockage. And then lastly, larger than anticipated amount of tails remaining after pumping. Like I mentioned in the first risk, this could cause the project to exceed its budget and delay the completion of the project. Next, my colleague will carry on.
Hello, my name is Ryan Stewart. I'm going to talk about our monitoring system design. I'll start out with the underground monitor. So we're going to have 5 wells to monitor our underground mine, which you can see here in the southeast corner, big chunk of area. And then we're going to have 5 wells to monitor the tailings pile. The purpose of these wells is to monitor the water composition inside the tailings, as well as in and around the underground mine, and to monitor the groundwater. Specifically, we're going to be monitoring here's a picture of the tailings pile, and for this, we are going to need to install or build a downstream monitoring facility, which will be concerned with water leaving the tailings. Specifically, we're concerned with the flow rate of the water. We'll test that using WARES. The composition of the water, we'll test that using ion-specific electrodes and a turbidity sensor. And the temperature of the water, and we'll test that using a thermocouple. Next, we're concerned with water entering the mine. For that, we're going to monitor precipitation using a pluviometer. Next, we're concerned with water seepage rates. To measure that, we'll test for electrical resistivity, and we'll use a surface resistivity sensor array, which you can see there in red. Next, we want to monitor surface water. And for that, we're concerned with the composition of the water, which we'll use ion-specific electrodes to monitor that, as well as a turbidity sensor. We're also concerned with the conductivity. We'll use a conductivity sensor for that. The temperature, we'll use a thermocouple. So to test for pH, we use a conductivity sensor. And for the pressure, we'll use an advanced tensiometer. And finally, we want to make sure that our tailings slope is, or we want to make sure the slope is stable. And for that, we'll use LiDAR.
For this project, we primarily used De Beers Group public domain data for the Schematic mine. Thank you for watching our presentation.